As you just said, Christelle, there is also a part of the work that was numerical and carried out by the University of Nantes. So I'm not a specialist about this part, but I will try to give you just a short overview of what was done during this work. I will go very fast on this part. The idea here was to develop a 3D finite element model to predict the soil behavior under cyclic and multidirectional loadings, to perform then a sensitive analysis to investigate the effect of the pile geometry, the load characteristics, and the load historic, but also the load multidirectionality, and finally to compare the behavior of shared and unshared pile anchor to clarify the effect of pile sharing on the lateral pile displacement. Just a short overview of the model. So the model considered a pile into sandy soil. So we only considered this type of anchor and this type of soil with the dimension mentioned in the slide. So you can see them here. The soil monopile interface was modeled using the Moore-Coulomb friction law, and the soil models was considering two types of law. The first one is the hypoplastic constitutive model that was compared to the sunny sand also constitutive model to simulate the soil behavior. And so the FEA analysis were performed using Abacus, the Abacus software. Some outcome of the sensitivity analysis. So the pile diameter was proven to have a high impact on the pile lateral capacity, while other parameters were not having the same effect. The pile lateral displacement is sensitive to the cyclic load magnitude, zeta b, which is calculated as H max over HR, and the pile lateral displacement increases with the increase of zeta b. Also, we highlighted that for a prescribed cyclic load amplitude, the pile lateral displacement increases with the increase of zeta c. In particular, one-way cyclic loads leads to large pile displacement, and precycling in a given direction affect the soil rigidity in other directions. For multidirectionality, multidirectional isoload sensitivity shows smaller pile lateral displacement compared to multidirectional non-isoload, as you can see on the two bottom scheme in this slide. Sorry, I'll move very fast on this part. If you have questions, I recommend you to ask them in the Q&A part. We can try to answer them, or we can address them directly to the responsible of this work at the University of Nantes, which is Abed Soubra. Final findings about this work using the numerical model is the analysis of two types of loading at the anchor given by the work performed in CIMA. So if we look at the 80-meter depth catenary mooring and 0% chain, we saw that unidirectional loading, unshared anchor show more lateral displacement than shared anchor, and for multidirectional loading, so meaning in between environments, shared anchors show more lateral displacement. But overall, it's the unshared anchors case that exhibits the largest displacement. Meaning, if we stay with the unshared pile design, it is conservative and the design remains valid for this case. In the opposite, if we look at the deep water depth taut polyester mooring lines, we obtain also that unshared anchors shows more lateral displacement, and shared anchor shows significantly this time more lateral displacement with multidirectional loadings. Meaning, if you look overall, shared anchors exhibits the largest displacement for this case. So, as a conclusion, we can see here that classical unshared pile design is no longer valid if you want to design this type of anchor. So if we want to have some design consideration, we can say that multidirectional loading can increase displacement, but this is correlated with the configuration and loading types. It is a little bit too early to give generalized recommendation about the type of design, the type of mooring design impacting the anchor design for shared anchor, and it is just tendency that must be further proven in the numerical analysis. Also, in case of high unidirectional loads, extralateral displacement may be neglectable. As a way forward, finalization of the geotechnical numerical study with a comprehensive analysis of anchor loading should be carried, and to go toward the generalization of previous observation and recommendation for the industry. So as I said, we only did they only perform a detailed analysis on 2 cases, so it would be important to include more cases in this analysis and to further validate this case with experimental data. The validation of the numerical models with experimental results, so include more configuration and meta-ocean cases to do this validation, and also include vertically loaded cases, because at the moment only horizontal loading were proven validate with the numerical model. Also, we can think about the development of simplified industrial tools for pile design under multi-directional uncyclic loading, extend the study to other types of soil and other type of anchors, such as, for example, clays or suction anchors, and look at long-term behavior of shared anchor under different extreme events.